Hi everyone, and welcome to lesson 6.7, the last lesson in this chapter 6 unit. So we're talking about surface area and volume with algebra today. So no new formulas, just learning about manipulating equations and how to figure out stuff if we don't actually have all of the numbers. So we're just going to jump into some examples here, and then we'll be done this unit. Okay. So example 1, we've got a soccer goalie is standing in an goal opening with an area of 17.52 meters squared. So we know the area of this. From this position, she leaves an area of 8.47 meters uncovered. All right, so that would kind of be like this part. Okay. And then we want to determine the dimensions of the net. Okay. So how do we figure this out here? Well, let's write a little bit more down here. I'm just going to fix this part. So we know that the area of the net is the 17.52 meters squared. We know the area of the uncovered is 8.47 meters squared. So the height, the width, we don't know, but we do know that the radius equals the height. Okay. So if we actually want to figure this out, we have to figure out the area of the uncovered equals the area of the net minus the area of the covered part, right? So the area of the uncovered part, they told us, was 8.47. The area of the net is 17.52. Now the area of the covered part, right, the part in here, that's like that semicircle part, right? So we know area of a circle is pi r squared, and if it's half of a circle, we can divide it by 2, okay? So this is like our half circle. Okay, so from here, right, we can just do some algebra. So we're going to move this 17.52 over, and we get negative 9.05. And then over here, we're left with that, right? Move this 17.52 over, becomes negative. Then we got to get rid of this 2, so we're going to multiply both sides by 2. So this is negative 18.01, which equals pi r squared. Then we can divide both sides by pi, right? Because we want to figure out what r is. So over here we get by negative pi, careful. 5.76 is our r squared. And then to get r by itself, we got to divide both sides by r. So r equals 2.4. Okay. So we figured out our radius, okay, but they didn't just ask us for that, they asked us for the dimensions of our net, okay. So our radius, in this case, we said it equals the height, right? So we could say, therefore, the height equals the radius, which is 2.4 meters, okay. All right, so the other thing that we have to figure out is the width. So area is going to equal this width times the height, and the area of our net was 17.52. We're looking for the width, and we just figured out what the height was. So all we have to do is divide both sides by 2.4, and then our width is 7.30. Meters, not centimeters. Okay. So we could say, therefore, dimensions of the net are 2.4 meters tall and 7.3 meters wide. Okay? Alright, so let's try another one here. So for this one, we've got the Earth has a surface area of 509,904,262.8 kilometers squared. It's pretty big. We want to know what is the Earth's diameter. Okay, so we have to think of surface area of a sphere, right? Earth is a sphere. And surface area of a sphere is 4 pi r squared. And they want us to know the diameter, or to find out the diameter, which means that we will have to figure out what the radius is first. So I'm going to rearrange my equation to solve for radius. So divide both sides by 4 pi, and we've got surface area equals 4 pi, or equals radius squared. Square root both sides. So my radius is the surface area over 4 pi and the square root of that. Okay, so the the surface area, 509,904,262.8, all divided by 4 pi and the square root of that. So thankfully we have calculators and we can do this all in our calculator, and we end up with 6,370.0 kilometers. But we want our diameter, so diameter is just 2 times the radius. So 2 times this, and we get 12740.0 kilometers. So therefore, diameter of the Earth is 12740.0 kilometers. Okay, and then part B wants us to know what the surface area of each hemisphere is. Well, surface area of a hemisphere is just a regular surface area of a sphere and divide it by 2. So we're going to take our giant surface area, divide it by 2, and we get 254,952,181.2 kilometers. Right, so therefore surface area of the hemisphere is 254,952,181.2 kilometers. Whew, that was a lot of words. Okay. So example 3, we've got a cone-shaped paper cup. Okay, so one of those paper cups they like give you at the dentist sometimes, maybe. Okay, cone-shaped paper cup. It has a volume of 67 centimeters cubed, and it has a diameter of 6 centimeters. What is the height of the paper cup to the nearest 1/10 of a centimeter? All right. So we have to look back at our volume formula. So volume of a cone is pi r squared h over 3. And we're looking for height. So let's rearrange this for height. So we're going to multiply both sides by 3. So we've got 3v equals pi r squared h. Divide both sides by pi r squared. And we end up, oops, not a 3. I need a pi. Pi r squared, and that is h. Okay, so let's plug in what we know here. So the volume is 67, pi, and radius, they gave us the diameter, so if we do that, 6 divided by 2 gives us 3 centimeters for our radius, and squared. All right, so if we do all this, again, we can do this in our calculator. We get the height is 7.1 centimeters. So therefore, height of the cup is 7.1 centimeters. All right. So next, we've got playing chips from a board game that are stored in a cylindrical plastic case. So this would be our plastic case over here. The plastic case has a volume of 25,120 millimeters cubed, and it has a diameter of 44 millimeters. What is the height of one playing chip? So we wanted to know this little height here. If 50 playing chips fit tightly into the plastic case. So we know that this is 50 chips. Okay. So we're gonna need, we know we're gonna need a radius. So for this one, right, radius is gonna be 20. Okay. So if we take a look at this, let's see. We know that the volume of a cylinder is pi r squared h. Okay. And then if we look at this plastic case, so the volume of the case is going to be that pi r squared times the height of, again, the case, right? So let's fill in a little bit about what we know. So we know pi, I'm just going to leave the radius for right now. And the height of the case we know is 50 times the height of the chip, right? Because we said that this is 50 chips. So 50 heights, okay, is the height of our case. All right, so I want to solve for the height of the chip. In order to do that, right, we're going to divide both sides by 50 and pi r squared, right? Because then that just leaves us with the height of the chip. So we've got the volume of the case is 50 pi r squared, and then that just equals the height of the chip. Okay, so now we can kind of fill in what we know. So we know that the volume of the case is 25,120. We've got 50 pi, and then the radius for the chip is 20, and that's squared. And that's going to give us the height of the chip. So if we do all this in our calculator, we get 0.3998 is the height of the chip. But then they asked us, did they ask us? Nope, they didn't ask us for like an exact number, but I'm just going to round this to a better number. So I'm going to say that the height of the chip is just 0.4 millimeters. Okay. So therefore, the height of one chip is 0.4 millimeters. All right. And last one here, Patrice is in charge of the excavation for the foundation of a building. If a hole must be dug that is 35 by 25 by 12, so we're assuming that this is a rectangular looking hole. Alright, so if we have length is 35, width is 25, and my height is 12. We want to know how many trips will be required to remove the dirt if a trailer can carry only 15 cubic meters of dirt. So the volume of the trailer is 15 meters cubed. Okay, so we need to figure out what the volume of the hole is first, and then we have to figure out the number of the trips. Okay, so let's figure out the volume of this hole first. So the volume of the hole is length times width times height. So 35 times 25 times 12. And we get 10500 meters cubed. Okay, so next we need to find the number of trips. So number of trips. So whenever they ask you a question like that, you're always going to take the volume of whatever you're trying to clear divided by the volume of what you're clearing it with. Right, so we're going to take our volume of the trailer divided by, the volume of the hole divided by the volume of the trailer gives us 700. So that means you have to take 700 trips. Right, so it will take 700. Oops. Sure, of course. My pen decides to die. $700 trailer trips to clear the hole. Okay. Alright, so that's the end of this unit. So make sure that you try the homework for this and then try the test review as well to prepare for the test for this unit. Okay, and ask any questions.